Today, let's delve into the Citroën 12B engine, an engineering marvel. We'll discuss its academic significance and unique features. Best of all, we'll compare it to its main German competitor to see who comes out on top. Shall we embark on this journey together? Historical automotive innovations. In 1949, the 12B model stood out in the automotive world. Its engine boasted 375 cubic centimeters, consisting of 12 boxer cylinders. These cylinders, made from an aluminum alloy, were finned for better cooling. The cooling system featured an axial fan directly connected to the crankshaft. This model had a compression ratio of 6:1. With a balance between bore and stroke, it achieved over 3,500 revolutions per minute, generating 9 horsepower. Despite modest torque of 20 Nm, it was sufficient to propel a 500-kilogram car. In contrast, the 1950 Beetle, its competitor at the time, had twice as many cylinders. With 1,131 cubic centimeters and a compression ratio of 5.6:1, it produced 25 horsepower at 3,300 revolutions. However, the Citroën had the upper hand in power per cubic centimeter, albeit by a narrow margin. The Beetle used a simple and classic gear-driven oil pump. Meanwhile, the 12B employed a more advanced G-rotor pump. This pump featured a 4-tooth central rotor connected to the camshaft and a 5-tooth outer rotor. This created a variable volume, resulting in positive displacement. Compared to the gear pump, the G-rotor was quieter, less vibratory, and efficient. However, the gear pump still had the advantage of simplicity and cost. Both pumps were easy to repair, consisting of only 2 moving parts. The lubrication process began with oil absorption by the pickup in the sump. The oil rose through a duct to the pump, from where it was distributed under pressure through the camshaft and the crankshaft's vanes. Some models included vanes in the connecting rods. Copper tubes carried the oil to the valve rockers. The oil radiator, made of aluminum, was located behind the fan, not obstructing the cylinders. In the Beetle, cylinder number 3 had delayed spark timing to compensate for excess heat and prevent detonation. The Beetle had a centrifugal fan, reliant on a large duct that redirected air to the cylinders. This design caused efficiency loss due to the change in air direction. The 12B, with its axial fan, promoted direct and efficient airflow. There were no chains or belts in the engine, as gears reliably and durably ensured synchronization. The camshaft controlled the valves through adjustable rods and rockers. Angled valves optimized airflow, not colliding with the cylinder walls. The hemispherical combustion chamber improved efficiency. The strategically positioned exhaust valve allowed the fan's air to cool the engine's hottest part, distributing heat evenly. Evolution of classic engines. Once upon a time, in a not-so-distant era, a common practice in engine engineering revolutionized our understanding of combustion. This technique involved heating the intake air to prevent fuel droplets from condensing. Thus, the fuel entered the cylinder in a gaseous state, mixing more efficiently with the air. This process resulted in superior combustion quality. Interestingly, the vehicle's exhaust pipes played a crucial role in this process, as they passed through the carburetor to heat it. It was an ingenious method, especially considering that technologies like electronic injection did not yet exist. The internal structure of engines from that era also featured remarkable characteristics. The combustion chamber, for example, was hemispherically modeled. Complementing this innovation, there was a specially designed piston with a cup that maximized valve opening. Additionally, it had side lobes, a feature designed to not lose compression, which could be caused by the well in the center of the piston. In contrast, the Beetle, an automotive icon of the era, had a different approach to its engine design. Its cylinder head, had straight valves. This configuration made it more economical and easier to build. However, this simplification resulted in a slight reduction in air intake. The Beetle's combustion chamber had a unique design known as inverted bathtub. This shape was not only more economical to produce but also reduced detonation, a common problem in engines at the time. Moreover, the cylinders of these old engines were designed to be easily removable. This meant that, when damaged, it was simply a matter of taking the cylinders to a specialized shop for a quick replacement with already machined parts equipped with new pistons. This maintenance system was remarkably efficient, significantly reducing the vehicle's downtime. Another interesting aspect was the construction of the connecting rods, which were made as a single piece. They had no cap or screws, as was common in other models. This simplified design contrasted with the more complex practices adopted in later periods. The 12B model engine, an exemplar of engineering of that era, had a quite peculiar feature in its crankshaft. It could be completely disassembled for the insertion of the connecting rods. This functionality made the process of turning the crank pins, the smaller parts of the crankshaft, extremely easy. It was possible to carry out this work on a small lathe. However, there's a point to consider about the 12B's disassemblable crankshaft. Despite its practicality, this feature slightly compromised the component's strength. This could be a disadvantage in situations requiring greater engine robustness. Nonetheless, considering that the small 375 cubic centimeter engine of the 12B produced only 9 horsepower and its top speed was limited to 70 km per hour, the reduced strength of the crankshaft did not pose a significant problem. Interestingly, the 12B did not use a conventional distributor to manage ignition. Instead, spark jumping was controlled by a rotor with centrifugal advances installed on the camshaft at the front of the engine. This system ensured that, whenever the piston reached the top dead center, the coil fired a spark. Interestingly, this happened in both cylinders, regardless of whether it was the correct moment for ignition. Although this approach was innovative, it resulted in double the wear on the spark plugs. This, in turn, halved the lifespan of these components. This design choice was a cost-saving measure, avoiding the need for a more conventional distributor. This ignition system was known as wasted spark. The first models of this engine were equipped with a 6-volt generator. Over time, this setup was upgraded to a 12-volt alternator, keeping up with the technological evolutions of the time. Another notable component was the flywheel. It was disproportionately large and heavy. This feature was essential to keep the engine running, especially considering that, with only 2 cylinders, there was a single combustion per crankshaft revolution during the compression and exhaust cycle of each cylinder. There was no additional impulse to keep the engine running, only inertia was responsible for maintaining rotation. This made the engine lose agility, especially in situations requiring faster accelerations. In contrast, the Beetle, with its 4-cylinder engine, had a different dynamic. There was always a cylinder in the expansion phase, constantly propelling the engine. This feature gave our beloved Beetle an advantage in terms of response and agility. Another interesting point is that it was possible to start the engine using a crank, the same one used to change the wheels, in case the battery was discharged. At the top of the engine was the carburetor, as well as the oil inlet. The latter also functioned as a ventilation filter or breather for the engine. This was a crucial functionality, as when the pistons moved into the crankcase, the volume inside it decreased. The generated pressure needed to be released somehow. Without this ventilation mechanism, the seals and gaskets of the different parts of the engine could burst due to excessive pressure, causing oil leaks. Over time, the engine underwent several modifications and improvements. Its size was increased to 425 cubic centimeters, reaching a power of 18 horsepower. Later, there was another expansion, this time to 602 cubic centimeters, raising the power to 28 horsepower. These enhancements allowed the vehicle to exceed 110 kilometers per hour.